Hello friends, welcome back to my channel. Today we are going to solve 23rd question from GATE 2022. This is a topology question. We are given a question map P from this space to this space. And this map arises from the characteristic function on this closed interval 1 by 2, 1. And T1 is the subspace topology induced by the Euclidean topology on R. And we have to find out which of the following statements is true. Okay, so in the options we are given P is open map or P is a closed map, so we have to find out if P is open, if P is closed. So let's get started with the solution. So basically P arises from the characteristic function on this closed interval, therefore we can write P of x is equal to 0 if x belongs to close 0, open 1 by 2, and it is 1 on this closed interval 1 by 2, 1, right? Okay, so what is a quotient map? If P is a quotient map, then P is a quotient map, right? So this implies V belongs to T2 if and only if P inverse of V belongs to T1. So a set is open in codomain if and only if its inverse image under the quotient map is open in the domain, right? Okay, now let us check if singleton 0 is open map. Now the codomain is 0, 1, right? So its subsets are singleton 0, singleton 1, the whole space 0, 1, and of course the empty set. So we have only 4 options for open sets, right? So let us find out which are the open sets. Obviously this is open, this is also open, so we just have to check if singleton 0 is open and singleton 1 is open. So first let us start with 0. Now what is P inverse? 0, singleton 0 is in T2 if and only if its inverse image is in T1, right? So what is P inverse of 0? P inverse of 0 is this 0, 1 by 2, because P of x is equal to 0 if x belongs to this interval, right? So P inverse of 0 is this semi-open or semi-closed interval, you can say. So is this open in T1? What is T1? T1 is the subspace topology induced by the Euclidean topology on set of real numbers. So this is open in 0, 1, T1, right? That is, this belongs to 0, 1 by 2, belongs to T1. So therefore, by the definition of quotient map, we have 0 belongs to T2, right? So similarly, is singleton 1, is it an open set in codomain? So let's find what is P inverse of singleton 1. It is this closed set 1 by 2, 1. But this thing is not open in domain, because if 1 by 2, 1 is open in 0, 1, T1, then there exists open set U, which is subset of R, such that U intersection 0, 1 is equal to this 1 by 2, 1, right? But there does not exist any open set U such that this satisfies, right? So that is why this is not open in 0, 1, T1. So therefore 1 does not belong to T2, right? Thus we found out that T2 is equal to empty set singleton 0 and 0 1, right? Okay, now that we have T2, let us find out P is open map or P is closed map or neither or both, right? Okay, now let us consider, let's write the definition of P again. It is 0 on if x belongs to 0 open 1 by 2, and it is 1 if x belongs to 1 by 2 1, right? Okay, so what is P of 0 1 by 4? This set is closed in 0 1, right? What is P of 0 1 by 4? It is 0, right? But is 0 closed in singleton 0 1? No, it is not closed because its complement singleton 1 is not open. Therefore, singleton 0 is not closed. So, image of a closed set is not closed here. Therefore, P cannot be a closed map. So, P is not a closed map, right? Okay. Now, let us check if P is an open map. Consider P of this one 3 by 4 closed one. It is 1, right? By the definition of P. Okay. Now, is singleton 1 open in codomain? No, singleton 1 does not belong to 2. But this is open in domain, and this is its image is not open in codomain. So this implies that P is not an open map, right? Because we got an open set whose image is not open. So P is not an open map. Thus, P is not a closed map and P is not an open map. So let's check if which option is correct. Okay, it's option D. P is neither an open map nor a closed map. So D is the correct option. Okay, so I hope you all understood this solution. See you in the next video. Thank you.